Hello students, today's discussion on microcontroller experiment number 6, timer. Actually in the experiment number 6 there are two programs we are supposed to execute. One is regarding timers, the other one is serial communication. Let's look into the details of the code. In order to understand this timer program, first we have to look into the aspect of what are timers and what is the application of the timer. And in order to operate this, how many registers are dedicated for this operation, and especially what is the role of TMOD register. TMOD stands for timer mode selection register. In that particularly for your experiments, lab programs, we are going to use timer mode 1 especially. So out of the 4 modes, mode 0, mode 1, mode 2, mode 3, we are going to mainly focus on mode 1, and we have to learn what is the procedure to operate the mode 1 timer, and how to generate a precise delay by loading a value, 16-bit value, how we can generate delay, and what is the formulas associated with this delay calculation, then how to write the program in the assembly code. So these are the contents we are going to discuss today. Let's look into the introduction part. What are timers? Timers mainly used to generate a time delay. It can also be used as a counter. So timers or counter. So the counter mainly used to count the external events. Event counters to count the events happening outside the microcontroller. So we have got two timers. Both are 16-bit wide. The namely timer 0 and timer 1. When we look into the bit specification of the timer, we have got two timers, timer 0, this is the timer 0, and this is the timer 1. Both are 16-bit wide. Start from D0 to the MSB is D15. Here also the LSB is D0 and MSB is D15. In order to use this particular register, we cannot use at a time 16-bit. It has to be accessed as a low byte and high byte separately. Like TL0 is an 8-bit. Similarly, the higher byte of the timer 0 is TH0, TL1 and TH1. So this is regarding timer 0 and timer 1 registers. And these two instructions, you can see the way we used the other instruction to move the register to register data, we can use in the similar context. You can directly load the 8-bit data, TL0, TH0, TH1 likewise. Similarly, the data which is available in the particular register can be moved to the other register directly by using this instruction. This is a register addressing mode. Regarding timer mode register, it's a very special function register to control the timer operation as well as counter operation. We have one dedicated register which is the 8-bit wide. Both timer 0 and 1 use the same register called TMOD, timer mode, to set the various timer operation modes. TMOD is the 8-bit register. The lower 4 bits are for timer 0. The 4 bits are dedicated for timer 0 operation only. Similarly, if I want to operate timer 1, you will have to go through this 4 bits only. Whenever you modify these bits, that will affect the timer 1 operation. In each case, the lower 2 bits are used to set the timer mode. Let's look into this detail in the next slide. When I set with a different combination, what happens and what it reflects, what is mode selection, and by doing that, how I can operate the timer. What are the different delays can be generated. The upper 2 bits to specify the operation. So here, the gate, especially this bit, is reserved to ensure whether it's a software driven or hardware driven timer. And this especially whenever there is a 1 is given to this bit, that signifies that it's a counter operation. Whenever there is a 0 is given to this bit, it indicates that means it's a timer operation to generate a delay. So that means in this bit especially decides whether we are going for counter operation or timer operation. So especially this particular discussion is restricted to the timer operation. So that's why this has to be kept 0. So the same 4 bits is copied for the timer 1 also in order to decide the mode, the counter or timer, as well as software driven or hardware driven. When we go deep dive to the particular aspects, what are the different modes available. So you can observe here when I provide this combination, this is called mode 0, where the operating mode is selected as 13-bit timer mode. So in the case of when this combination is provided to here 0, 1, that means we are operating in a mode 1 and it's a 16-bit timer mode. So we can generate maximum delay using this mode. So in our discussion, let's restrict to this particular mode only, because in your lab experiment we are going to see the 16-bit timer mode. For your theory aspect, you should know the other 8-bit auto reload as well as other modes also. But for the lab point of view, you should be aware of when I provide 0, 1 to this, accordingly the mode 1 is selected and which is a 16-bit timer mode. So focus on this, try to understand properly this one, and you can see the gate. What is for gate? The next slide, especially this talks about why we have to use gate. When we use gate as a 0, when this bit, especially this bit is 0, that means we are going to use it as a software. It uses internal clock, internal crystal oscillator to generate the timer delay. Timers of 8051 do starting and stopping by either software or hardware control. When I make gate 0, the start and stop of the timers are controlled by way of software by TR times start, bits TR0 and TR1. So this especially acts as a triggering pin. So in order to operate this set B and clear, we have two instructions to turn it on and start and stop. This instruction start and stop the timers as long as gate is 0 in the time mode register. If gate is 1, that is called hardware way of starting and stopping the timer by an external source is achieved by in the mode register. Now, say if I want to have a different mode of timer operation, so then by moving a particular data to the mode, we know mode register is a 8-bit register, and I move a particular data accordingly, it will set a specific functionalities. Let's look into the detail. If by using this instruction, what are we going to do? So you can observe here by moving 0, 1, if the binary equivalent value is this, accordingly mode 1 of timer 0 is selected. You can observe here. So by moving 0, 0, 0, 0 to that and 0, 0, 1, that means here timer 0 and here the mode 1 is operated here. Mode 1 is selected. Mode 1 of timer 0 is selected. Similarly, by moving these two data, you can observe, you can set different mode. Accordingly, you can generate different delay. Regarding programming aspect, we have to follow a set of procedure to operate the mode 1 programming. What are the steps need to be followed? There are around 4 steps to be followed. The first step includes, we know that mode 1 is a 16-bit timer. It's a 16-bit timer. We have to load a 16-bit value for that. So that's why to be loaded into the timer register TL and TH. So I can make use of timer 0 or timer 1. So if I make use of timer 0, this becomes TL0 and this becomes TH0. If I go for timer 1, this becomes TL1 and this becomes TH1. After TH and TL are loaded with the 16-bit initial value, the timer must be started. How to start a timer? When, as I already said, two control pins are dedicated to drive the timer register. One is TR0, TR0, which is dedicated for timer 0 driving, TR1 to drive timer 1. So this instruction I have to use to set or start the timer for timer 0. Similarly for set BTR1 for timer 1. After the timer is started, it starts to count up. It counts up until it reaches its limit of this value. So you can see internally the block diagram is given, and you can understand through this. When I make gate is equal to 0, that means we are utilizing the internal clock. That means through the crystal oscillator. So that means it is utilizing the internal crystal oscillator, and it is generating a clock pulses. This clock pulses is applied to the one of the AND gate, internal AND gate, hardwired AND gate, and the respective timer 0 and timer 1 is controlled through this pin. When this pin is on, then further count happens or timer ticking happens. So when this is 1, by using this instruction respective in order to make timer 0 triggering TR1 for timer 1. So when this is provided, so the internal clock is directly applied. As and when the clock is applied to this, so the loaded value starts incrementing. When it reaches to the maximum value, then it changes from, when again one more increment happens from FFF to the next increment becomes 0. So this condition they call it as a rolls over condition. So whenever this happens, bit is dedicated to notify this rolls over condition. So the timer flag indicates the status of rolls over condition. Further, the third step we can observe here, when it rolls over from this maximum value to the next value, which is the initial value 0 0, it sets high a flag bit called timer flag. This bit will be set. Each timer has its own timer flag. For timer 0, we have TF0. Similarly, for timer 1, we have TF1. When this timer flag is raised, one option would be to stop the timer with the instruction CLR-TR0. I can change this particular bit. The last step, after the timer reaches its limits and rolls over, in order to repeat the process, we have to reload the value. TH and TL must be reloaded with the original value, and TF must be reloaded to 0 for the next timer operation. In order to understand the programming to generate a timer delay, mode 1 programming, so all the steps, previously discussed steps, being briefed here. The first step we have to follow, load the T mode value register indicating this timer. Timer 0 and timer 1 is to be used, and this timer mode 0 or 1 is selected. Load registers TL and TH with the initial count value. Start the timer, keep monitoring the timer flag TF with the JNB TFX, the label. Instruction to see if it is raised. Get out of the loop when TF becomes high. Stop the timer, clear the timer flag for the next round, go back to step 2 to load the TH and TL again. Let's try to understand the programming part. The first task we have here, in the following program, we create a square wave of 50% duty cycle. That means the on period is equal, off period is also equal. So we have got an equal on period and off period, 50% duty cycle with equal portions high and low on the port 1 of the 5th bit. Especially we are going to use timer 0 is used to generate the time delay. Let's try to analyze the code here. So starting with, we have to select timer 0. So and mode 1, 16-bit mode need to be selected. So for that, this instruction we are supposed to use. We have to move the 01 data immediately to the P mod register, which is a 8-bit register. By doing this, we are going to select timer 0 mode 1, which is a 16-bit mode. Now, if I want to generate a particular delay, let me load a value here. So it's a 16-bit timer mode. So that means timer 0 is used, TL0 and TH0 must be loaded with the 16-bit value. Then complement the port 1 of 5th pin every time. So this ensures the toggling of the condition. So the first condition, let's assume it is 0. Now that will be complemented to generate the high portion high or on period. then we are calling it delay. So the first step is taken care, we have loaded. The second step is also taken care. Start the timer. So from here we have to ensure in the delay program. So you can observe here in the delay program set be T or not. We have to start the timer 0. Then we have to monitor the particular bit TF0. When the rolls over condition happens, the TF1 becomes 1. Till that condition achieved or attained, so it will be monitoring the same bit again and again. So jump no bit stand for when TF is 0, it will be in the same instruction, repeating again and again. When rolls over happens, that means from the maximum count FFF2, when it changes to the next count 0, so TF not become 1, then this instruction fails. So then it comes here, then as we know, we have to stop the timer, clear the TF flag. So through these two instructions we are doing this, and this is the subroutine program. We have to return to the main program. When we come back here, sjump here, again we are reloading with the same data, then again complementing. Here, how much delay is generated? So by loading this particular two data, F2 and FFH, to the timer 0, how much delay is generated? In order to calculate, we should know this formula. If we are doing in a hexa calculation, then hexadecimal calculation, we have to abide to this formula. If we want to do it in a decimal calculation, then we are supposed to use, we have to convert this hexadecimal to decimal value, then we have to use this formula. So these two formula we have to use, whether we are going for hexadecimal calculation, this formula must be used. What is this formula all about? See, the maximum value, the FFF is used here as a one quantity, subtracting the loaded value. The YYXX is nothing but the loaded value. Notice the value are in hexa. Then this +1 indicates it's a rolls over condition. After subtracting this, so the whatever value, say this is loaded in the previous program, FFF2, then after subtracting you are getting 0G, it is a 13 in decimal, +1 for the rolls over condition into 1.085 microsecond. This is obtained through the internal clock through the crystal oscillator. You can observe here. So the timer works with a clock frequency of 1/12 of the external frequency. Therefore, we have this value 921.6 kilohertz as the timer frequency. As a result, each clock has a period of T is equal to this value. In other words, timer 0 counts up each 1.085 microsecond, resulting in a delay number of counts into this value. That's how we can calculate for this loaded delay. For this loaded delay FFF2, we are getting around 15.19 microsecond for half of the pulse. So to get the on and off portion, equal off portion, so that means your program is generating around 30.38 microsecond as the time delay generated by the timer.